Corporate finance practice problem using Excel. Current payment, annuity, or future payment alternatives. In other words, we will compare and contrast alternatives of having a current payment or a series of payments and annuity or some future payment. Get ready. It's time to take your chance with corporate finance. Here we are in our Excel worksheet. If you have access to the Excel worksheet and would like to follow along, note that we are in the practice tab as opposed to the example tab in essence being an answer key. We're going to have the information up top on the left-hand side. We're going to put that information into the blue area on the right-hand side, typically with a mathematical formula, running balance calculation. Then we will do the calculation with the Excel formulas and then with the tables. We're going to be doing a comparing and contrasting this time of multiple different types of things we've seen in the past in a scenario where it's like a decision-making scenario between different options, being able then to compare and contrast these items as we go as well. So we have a current payment, an annuity, and a future payment. We have a decision between these, which one would we want to take? For example, here we got the current payment of $8,000. We've got the annuity then, which would be the $2,000 payments for 8 years. Or we have the future payment, meaning we could receive in the future $29,000. So our question then is, which one would we want to take? Obviously, this would differ in terms of with regards to our circumstances. If we needed the money today, then we might say, I need the $8,000 today at this point in time, or possibly you might say I need at least the $2,000 currently or sometime soon, and that might influence the decision-making process. Or you might say, hey, look, I would like to invest this money, so I'm going to look for the one that's going to have the best value to me over the full time frame. Then you're going to have to look for some type of discount rate, which is going to be an estimate to figure out what the discount rate which would be appropriate, which you might take into consideration, say, inflation, as well as what you can do with that money if, for example, you had it today. So if I had the $8,000 today, what could I do with it if I was to be comparing with it to get a return on it possibly, and then compare that to the annuity situation and the future value situation. So our goal then is to find this rate that we're going to have for our discount rate. Once had, then we can present value these different scenarios and then do a comparison, same thing to the same thing, or apples to apples, as some people say, same thing to the same thing. That's what we're going to be thinking of doing. So let's first present value the annuity. So this one up top, obviously the payment is the present value. That is the present value payment. That's in today's dollars. If I'm trying to compare that to an annuity, where we're going to get $2,000 for 8 years, we're going to say it's in years, then obviously the full payment would be $16,000, but it being an annuity means we're not going to get it today. We have to take into consider the time value of money. So let's do our annuity formula to bring that back to the current value using our annuity calculation. That's going to be this one down below, P, and we're going to say 1 minus 1 plus R to the negative N over R. We're going to have the P times this whole thing in the middle on the outer column, and then we'll bring into the inner column the numerator and the denominator calculations. Let's go ahead and highlight this one too. This is the one we're focusing in on now. This is the annuity calculation, annuity. And we'll start off with the 2,000. So let's pick up the 2,000 here. And then we're going to have the 1 minus this whole thing. So I'm going to put 1 here. And then I'm going to have the 1 plus R to the caret, or to the power of the caret negative N. So we'll say this is going to be 1 plus R, which is going to be the 10%. And then we'll percentify that. Home tab, numbers, percentify. I'm going to underline it, home tab, font, and underline. Then we'll sum this up, equals the SUM of these two items, summing that up. Percentify in this number, home tab, numbers, percentify. And then we're going to take that to the negative N. And so we're going to say this is an annuity, that normal annuity, where the first payment basically happens at the end of the period. So I'm going to say this is negative 8. And then we'll pull this into the outer column. Let's go ahead and underline it first. Home tab, numbers, underline, pulling this to the outer column, this being equal to the 110 caret or shift 6, and then the 8. Let's add some decimals here. Home tab, numbers, decimalizing the cell. And then we'll underline it, home tab, font, and underline it. So now we'll do the subtraction, subtracting this out. This is going to be equal to 1 minus that amount. Adding decimals to it again, home tab, number, decimalize, making it a little bit more exact. Now we have the numerator in these brackets. Let's pull in the denominator, which is simply the discount or 10%. 10%, percentifying that cell, home tab numbers, percentify, underlining it, home tab font, underline. And then we'll bring this into the outer column. We have the numerator and denominator, therefore we can just simply divide them out. Numerator over divided by denominator. Adding some decimals, home tab, numbers, decimalize. Adding some decimals here, and then we'll underline this one. We're going to go then home tab, font, underline, and now we can multiply this out. We got the P times the whole thing in the middle. This is going to be then the 2,000 times this thing we just calculated. Let's add a couple decimals this time. Home tab, numbers, just 2 decimals, and that gives us to the 10,669.85. So because this number is greater than the current payment, then you would think that the annuity would be beneficial to the current payment in that situation. That discount rate is taking into consideration kind of like the time value of money, meaning if you had the money today, you're trying to figure out how much that would be worth to you today versus in the future, you take into consideration the discount rate to do that, valuing what you could do with it today, either spending it or if you were to invest it, what you can do with it on an investment kind of standard. And so this one being higher, then we might be choosing then the annuity then. Let's go to the future value of one, or I'm sorry, let's do this annuity again, this being a series of payments. Let's break that annuity down into a series of present value calculations. I'll do this a little bit more quickly because we've seen this in the past, but this is another way you could see this, quite common type of way, and this could help you better visualize what's actually happening with the annuity. I'm going to select 1, 2, select those items, and then autofill down. Then home tab, alignment, and center it. We're going to have the payments. The payments are going to be the 2,000, and then we'll simply use the present value calculation each time for period 1, 2, and so on to then period 8 to have 8 present value calculations that we will add up, getting to the same result, hopefully, if done properly. We're going to say this is going to be equal to, I'm going to say negative to flip the sign instead of equals, and then present value. So present value, and then we're going to pick up the rate, which is going to be the 10%, comma, number of periods. This is going to be 1 rather than 8 because we're just looking at that 1 period out at this point in time, comma, payment. We don't have one because this is not an annuity calculation. This over here was an annuity calculation, but this is a payment of 1 calculation that we are then going to add up to get to the annuity by adding up 8 payments of 1. There's the 2,000 and enter. So there's what we have for after the first period. Let's do this again. 2,000 happens again for the second period. Present value is going to be equal to negative. I'm going to say present value brackets. The rate is the 10%. 10% on the rate, comma, number of periods. Now 2 because we're talking 2 periods out, comma, comma. Because this is not an annuity calculation here, this is the present value and then the 2,000. Then we would say this would be the prior amount plus the current amount and so on and so forth. Let's do a running balance or use the autofill format now. I'm going to double click on this value and see if there's any numbers that I need to make absolute values. This 10 down here needs to be absolutized because I don't want it to be moved down as I move down the cell. That's going to be in B12. So B12, I put my cursor in B12. I select F4 on the keyboard, putting a $sign before the B and 12, making it an absolute reference, telling Excel, don't move that down when we copy down the formula. You only need a mixed reference, by the way, for picky people, but the absolute reference is easier to use sometimes, so I just use that. So we're going to select these items and then copy them down, autofill, and this gets down to that 10, 6, 7. Let's go ahead and add some decimals to make it a little bit more exact. Home tab, numbers, couple decimals, and there it is. So we've got the 10,669.85. Now let's do it with a formula in Excel, annuity calculation on a formula. This is going to be equal to the present value, this time an annuity calculation, starting off the same as the calculations we did before, meaning we're going to pick up the rate here, for example. Same rate, 10%, comma, and then we've got the number of periods. Now the number of periods is going to be 8 because this is an annuity as opposed to a payment of 1, comma, And then we're going to pick up the payment as opposed to skipping the payment and then doing the future value, because once again, this is an annuity as opposed to the present value of one calculation. So there we have that. And let's double click on it again, put a negative before the P to flip the sign at that 10,669.85, matching out another time. Let's do it with the tables. Table time, same thing with the tables, thus named table time. And so now we're going to go back on over here, pick up the table, make sure we're picking up the proper table, which is an annuity table. And we've got the percent at the 10% and 8 periods. So 10%, 8 periods is down. Well, I'm going way too far down. Where am I going? 10%, 8, that's going to be 5.3349. 5.3349, 5.3349, 5.3349, 5.3349. Decimalizing it. Home tab, numbers, decimalized. 5.334 now. Underline, home tab font, underline. And then we can multiply it. This is going to be equal to the 2,000 times that number. Adding a couple decimals here, home tab number, couple decimals. And there we have it. Not exactly the same number as over here because the tables use rounding. It rounded only to 4 digits. So a slightly different number would be good enough for our decision-making purposes here if we were to use the table format, of course. So then if we go back on over, let's do it again. Now this time we're going to analyze this option. So now we've taken a look at this. This is, we don't have to do anything to that one because, you know, like it is what it is, pretty straightforward. This one, however, we just figured out, now we're gonna present value this one. He's saying, well, what the other option is we get 29,000 after 8 years. So now I gotta wait 8 years before I get any of it, as opposed to getting this today and that in an annuity type of format. So now we can present value that. We'll use the same discount rate. We're gonna use this formula, present value of one formula, to bring it all the way back from 8 years out to the current day. So we'll do that over here. We're going to say we'll start off with the future value, the 29,000. And then we've got the 1 plus R to the N. So this is going to 1 plus R, which is 10%. Percentifying that, home tab, numbers, percentified, underline, home tab, font, underline. Adding them up. I'm going to use the sum function equals the sum of those two items. Then we'll percentify it, home tab, and number percentify. And then we're going to take that then to the power of n. To the power of n, number of periods, which is 8. Underline that, home tab, font, underline. And then this is going to be that number to the power of, which is shift 6, 8. And there it is, percentifying this, home tab. I'm not going to percentify it, adding decimals, home tab, numbers, decimalize. And then home tab, font, underline. And then we can do the division problem. This equals to 29,000 divided by that number, adding a couple decimals, home tab, number, couple decimals. And then if we want to see what would be found on the table, we can take basically this number divided by this number, and that'll give us the amount we expect to see on the table, but the table will take it out only to the 4 digits. So we'll see that shortly. So we're at the 13,528, the 13,528, which is higher, I believe, than what we calculated before. So this option is 8,000, so it would be higher than the 8,000. And the last option was 10,669. So this option, using this current discount rate, would be the best option. Obviously, it would be dependent to some degree on the discount rates that we would be using. So you could then, once you have this properly into an Excel worksheet, you could then alter the discount rates to run basically different scenarios and then see, you know, what you would think in the event that different scenarios were to take place. Let's go to the present value calculation with a formula now. This is going to be equal to the present value of one calculation. So present value, picking up the rate at the 10%, comma, number of periods. This is going to be 8 periods, comma, no payment because this is not an annuity this time, but a present value of 1. So I'll just put another comma there. And then we've got the future value, which is the 29,000, and enter. So there we have it. Going to double click on it, put a negative before the P to flip the sign. There's the 13,528.71 once again. Then we'll do it with the tables, table time calculation, same kind of thing, but with the tables. Just making sure we're picking up the proper table this time, not an annuity, but present value of 1, 10%, 8 periods. So we're taking 10% over here, periods 8, which are going to be down here. And that's going to be the 4665, 4665, 4665, 4665, 0.4665. Add a couple decimals, home tab, number, like 4 decimals, a few decimals, I guess. And then home tab, font, and underline. Then we'll multiply it, the 29,000 times that number, add just a couple decimals, home tab, number, couple decimals. There's the 13,528.50 versus the 13,528.71, slightly different due to rounding 4 digits out on the table, versus over here where we would have thought if it was more than 4 digits, 0.466507 versus the 0.4665. The rounding isn't going to typically sway your decision between the alternatives if it was in practice, but remember that book problems, test questions might take advantage of the rounding to force you to use one method or another. So that's going to be the general kind of system you can do. Obviously, if you had Excel, you'd probably want to be setting up this system and possibly do like a running balance type of calculation so you have a better understanding of it. And then you can vary something like the interest rate, which is the estimate that you're using to decide which would be the best alternative, running different scenarios in that format to help make the most informed decision.